Okay, hello. So should we give a few more minutes maybe, just in case?
Okay, yeah. See, we have Robert. Robert's a frequent attendee, and Marta, so I appreciate you both.
Marta, that you're from, it's ANL, right?
Yes, thank you. Sorry, if you want me, I can change. I don't know why by default it's just my name. I have a very short question whenever you start.
Go ahead, start.
Is eventually I have some users who have the H5 part format, and I was wondering if is that, well, you mentioned the other day, but if you want, I don't know, for the audience, if is that something that I should recommend to transition?
Yeah.
Because I'm digging in, I have a more idea of what they are doing, so I will be able to share that with you this week, hopefully, but is to prepare recommendations. So is that some, I still have to find out what is the purpose of that, if it's something that they want to keep, or if I can suggest to move somehow inside a normal H5 file, or I know if you have thoughts also for the audience.
I mean, it is an HDF5 file. It just has a certain format. So most of they're probably using it for, I'd assume, for visualization, because most of the visit and pair view, they can all read H5 part. The thing is, I think my understanding that H5 part's no longer really supported. No one's really activated it. So it's probably using very old HDF5. I haven't looked at their implementation of it, but it's probably pretty old, and they probably don't have a lot of the newer features of HDF5. So it's probably not as efficient as it could be, given the fact that it's there's nobody really working on it that I know of. That's my understanding. So they should probably transition away from it. And I think that's why they're using XTMF. Because that's essentially the same thing. It describes the data in the HDF5 file, but it's an external instead of all in one package, which is H5 part.
H5 part would actually be one of the good candidates for the multi-dataset code too.
Yeah. Quincy, I'm correct though, that I don't think anybody, because I think it was LBNL that was kind of leading that effort, I thought, and I think it's kind of gone to the wayside, on my understanding. It hasn't been updated. I don't even know.
It hasn't been updated or tested in a long time.
Yeah.
Okay, thank you. Then I will probably suggest all the above. Thanks.
Although XDMF is kind of in the same boat. Kitware is kind of hosting the code, and I think as I talked to Kitware, they kind of, I think the Army is one of the DoD branches is kind of leading the effort in keeping it alive, but I don't think that's also not really actively updated either. Although but it's still probably better than H5 part alternative.
Which one is that? The
XDMF.
XDMF. Okay.
That's the one where they do an XML file to describe what's in the HDF5 file.
But that is also something that they should probably transition to.
No, there's nothing else to transition to, unless you want to choose a different format, which, I mean, like a standardized format, which for particles, I don't think there are really any for particle physics.
So it's okay if they keep the XMF files? Okay.
The one thing that we have kind of gone back and forth is we really wish that they could read a field and a compound type, because we've noticed that writing a compound type usually performs better, and applications like VPIC have moved from writing individual data sets into packing it into a compound type and then writing that, because essentially you have one big write then, which always performs very well on a parallel file system. But the problem is you'd have to post-process that file for XDMF because it can't distinguish fields in a compound type. It needs a data set to point to.
That eventually wouldn't be, may not be such of a problem in the sense that I talked with Joe, who is the one helping in the visualization, and the files that he uses for visualization are some kind of solution post-process. So it may be not such of a problem, but I write a note. Thank you so much.
Mhm. I guess I was going to give a preview of some of the new features in HDF5 for parallel, if people are interested in that. It's kind of a precursor to what's going to be talked about on the September 30th webinar that was just sent out, basically subfiling and multi-dataset. I think Marty, you've already seen this because I gave it at the talk, but I can.
But I'm happy to relearn it. Don't worry. I'm here even, in fact, for that to be exposed to all
Okay,
your features. So
let me share my screen and then I'll just give a little. It's just a small little overview of what the two features are.
Yeah, that's great. I just put in the chat, I put the link to register for your webinar on September 30th. And while you're getting organized there, Scott, so Scott was so gracious to jump in for Gerd, and we'll have a series of substitutes. And we may shake things up when Gerd, he's traveling when he returns. But so Scott this week, and then I think it's John Reedy. No, I'm sorry. I think it's Alexandra, who's our Python expert, will be next week. And then John Reedy, who's our cloud person, will be the week after. So all questions are welcome, as we always have done, but they have specializations that may be helpful to people. So thank you so much, Scott, for doing it this week.
Mm-hmm. Yep. So for subfiling, it's basically a compromise between a file per process and a single shared file. And basically it organizes multiple files in a software type RAID implementation. So you can set the stripe depth and the stripe size. So the stripe depth, or sorry, the stripe set is the number of subfiles you'd have per node. And the stripe depth is the amount of data that each subfile gets written to in a block 1, block 2 type situation, RAID 0. So what we notice is that you get better performance parallel IO using better performance out of the subsystem when you do less number of, or when you don't use a shared file. It also can, it can reduce the complexity of a file per process. So instead of having millions of files, you'd have a subset of files associated with number of nodes. And then it also helps reduce the locking contention that you might see if you have a single shared file and a large number of ranks. So just to give you an overview of what it is, it basically has an IO concentrator that runs on a node. And then you can this IO concentrator aggregates the data on a node, and then you can either write it to a node local storage if that's an option on your machine, or it can persist to disk. And it's very simple to implement, or to implement in your code to change it over. So you have subfiling, you have a file access property that you, instead of usually, if you have a parallel code now, you'll just, instead of calling the MPIO driver, you will set the FAPL to the subfiling VFD. And then you do create your file just as normal. And you control, there's two options. There's the null, this null parameter that we usually pass. This is a struct that you can set these variables, or you can use the environment variables to control them instead and set that to null. So you can set the number, some of the important ones are the number of IO concentrators per node. So that's the number of subfiles, the stripe size, and then the number of background or threads that the IO concentrator uses. We have noticed that with the stripe size if you use H5P set alignment, that if you also set that the alignment value to be the same as the stripe size, you get pretty good performance compared to not having them the same. Just some early results that we've got from IOR, and this is Polaris at A&L. So this is one subfile. This is a use default, so it subfiles one subfile per node, and the stripe size was the same as the Leicester stripe size, and it was the same as the P alignment that we set. And you can see that it performs. So the purple is the independent. The green is using collective HDF5. These is a single shared file, and then the blue is the subfiling. You can see that this is the right bandwidth, the number of processors, and you can see that it performs pretty well. Another feature that we're coming out with is the multi-dataset. This has been in the works, various stages for a long time, and it's kind of coming to fruition. And this will be available in the next major release, which is 1.14. So basically, with HDF5, you can write data sets, variables and conditions, and I/O is performed on a data set, per data set read and write, and you're only limited to doing one data set at a time. But many applications, you want to perform I/O multiple data sets. So for example, if you have a vector of 3 components, normally you'd have to write call H5D write for each component. We'd rather have an API that writes all 3 components at once, because you usually get better performance, because that would just aggregate the I/O requests into using a single MPI file, write or read, whatever you're doing, and whether it's collective or independent. So this should get better performance especially if you have a lot of data sets. You'll definitely see an improvement over writing each individual data set. And so the new APIs will look something like this. What you'll do is you'll loop over your data sets, create them, and then you'll pass in those arrays. So you'll make the count is the number of data sets you have. The data sets ID is an array of the data sets returned from the H5D create. You have the mem types for each of those data sets, the mem space for each of the data sets, arrays, and a file space. And then you have a big buffer of all the data sets you want to write. So I guess one disadvantage over multi-data sets is you have to, if your application is memory locked and what you're doing is allocating, writing, deallocating, then this might not be an option for you, because you have all the data sets allocated for that write or read. So that's all I have for data features coming up. Any questions about new features? And then you'll hear more about this in the September 30th talk. We'll go in much more detail. I just want to give a heads up on stuff that's coming in down the pipeline in HDF5.
Yes, Scott, eventually, since you mentioned this, and I was looking at the files from these particular users, they have groups and they have data sets. Based on this multi-data set, do you have to go inside the data set of the groups, or is better, what would be the order? Do data set in groups, or do you have to do them all? I mean, it will make more sense if I share the screen, but it's recording, so probably I don't want to confuse. So when you want to take advantage of this multi-data set, you have this list. The file that I have, for example, contains groups and some data sets, and then more groups and more data sets. So how do I do that? Should I extract the data set from the groups? And you know what I mean? It's like you have different folders.
If you, for example, have a group 1 and you have a data set 1 in that group 1, and you have a group 2 and a data set
yes,
2, right?
And then at the same level of the groups, I have other data sets.
Right. Yeah. As long as you give that array of data set IDs that's returned from that. So you'd open the group and then create the data set of that group. and that returns, right, the dataset ID. As long as you return the dataset ID of that, it should work.
So I should do the data
can keep-
sets.
right,
I
you can
can
keep
keep
the
them in the
groups.
groups. Okay.
Yeah,
Okay.
yeah.
Yeah. To be more categorical about it, any open data set can be part of this call. Doesn't matter what group it's in.
Right.
So in theory, I could put them all in just one data set ID? All the list?
Would
of
work too, but
many of it
any
has-
number of data sets and any number of groups doesn't matter, right? You can put your data sets anywhere in the group hierarchy and they can be part of this call.
Right. As long as you have a data set ID return from whatever, as long as you use that, it doesn't really matter what group they reside in.
Okay, thank you so much. And so will that be the best option in principle, like to get everything? Will make it faster, or will it slow down? Should we evaluate how many, I don't know, IO nodes there are or something like that?
It depends. It works better the more data sets you have. I mean, I did it for CGNS, which is the CFD standard, and we showed about 10% improvement, but it was only, I think it was only combining it was 9 data. So it was 9 data sets into essentially would be 3 writes. So, and it wasn't a large improvement, but I think it's more geared for people that are creating thousands for some reason data sets, right? And that would really hurt a parallel file system if you wrote, I mean, if you're writing thousands of writes compared to just one big write, it's always going to be better with the one big write. So it really depends how many data sets you have, but in general, it should improve.
Okay,
So-
thank you. Maybe this is an alternative because the current file, that is the dump file, has 179 data sets in a mix of some of them are in groups and others are alone, but this is kind of the other 200. Probably
Yeah.
I
as we-
will see an impact.
As we mentioned, though, that they're creating a lot of those little data sets that you probably want to get rid of anyway. You don't want to, even if you have multi-data set, you probably don't want to have all the ranks writing those little data sets that are basically all the same.
Yeah.
I think you should still avoid having ranks create a data or write to a data set that they're all writing small, the same data to each data set. I think that's what they were doing.
So in fact, I have to double check what is the information. Just now, I just have an information of the HDF5 file, but I mean, with the HDF5 view GUI, but I have to attach the information of how many doubles of integers are they writing for each. Thanks.
Right.
That's
One, they were
useful.
just, I think they were adding an array of 1. So, which they just did a great scalar, but, and I think they were having all the processors do that. I don't know. I didn't look I have to look again, but yeah, you want to check that. Because even if that, you don't want, well, even if you use multi-data set, you still don't want to do that.
Thank you.
Mhm. It's also, you could look into async if you think that might be helpful too. And multi-data set will have async versions of it. So that's also an option. But then you have to either use a vol that supports async, such as the async vol itself or Deos.
That should be okay, I think, on Aurora. So potentially
on
it is an
Aurora.
option.
Mhm.
Thanks. Eventually, another question regarding the slide that you had about the striping. So if we have already a striping in Lustre, and we can add like a line, set the stripe, blah blah. Does it interfere with this striping, or is the same? Do you know that?
No, it's different. The stripe size is the size that gets written to the file, the subfile, where it might not correspond to what the luster stripe size is. It's probably a good idea to have it in at least multiples
So what is
of
this?
each other.
What is this size? So this is something coded in your application. We have to
No, it's in
modify.
it's in the sub. It's how the subfiles actually get written. So if you have 64 or 128 megabytes, and you had a stripe size of, and you have 4 subfiles or something, it's going to write the first 32 bytes to the first subfile and the next 64 bytes to the next subfile, and then it keeps repeating that. So that's the amount of data that gets written each time to a subfile in a round robin type of way. So if you look at the first, see it does a block. So this is that block size of 1 would be the stripe set. So in this case, if it's default, it's going to write 32 megabytes. The next block is going to be 32. So these are for the subfile. So if in this case, there was 2 subfiles, right? So block 1 will be 32 megabytes. The next one will be another 32. And then it'll go back to the first subfile and write the next 32 megabytes. And that's how it's going to get written. So if you think of your luster, then it's going to be for that, I guess, node, it's going to write in 32 megabyte blocks. So if you have a stripe size of 32 megabyte, you're probably going to get better performance as if they weren't aligned with what the stripe depth is for luster. Although we haven't looked into it, and we plan to look into studying that type of performance probably in the next few months.
So if your next slide, if I load whatever is the module that we have on, no, excuse me. Yeah, this one. Yeah. So if I can write those environment variables and I will see the values if I have a module HDF5 load. So, okay.
There's H5P get FAPL subfiling, and that returns that struct, and that will return what those are set at. So if you set them in the environment variable, they should show up in that struct. So if you do H5P set and you pass null, and then you create it, and then you set your environment variable, it should, when you do H5P get FAPL subfilings, it should have whatever you set in the environment variable in that struct.
Okay, thank you. So I have to modify the code. It's not that I get those outside in like a export or echo this value.
I mean, no, yeah, you do export those environment variables, and that would set it. You still have to call,
they are not by default. I don't see them by default. What is the value that was?
not unless you do H5P get FAPL subfiling.
Okay.
If you do get, then it will return the defaults. And if you want to then change the defaults, you can change them in that struct and then pass the FAPL back to the set subfiling.
Okay, thank you. I will print them.
Mm-hmm. But just a reminder, though, that the subfiles have to be, if you're using, for example, like XTMF, you have to reassemble those because those subfiles are kind of broken up into file. I mean, they're not standalone. If you look at it, they won't be a valid HDF5 file. You have to assemble it, and there's a tool called h5fuse.sh that will reassemble those subfiles into an HDF5 file. And then you can use like a reader to dump it, or for example, XTMF. So you still have to post-process those subfiles, which might not be cheap. But you can that's the kind of thing you can do in the background too. If your simulation's running, you should be able to, you might be able to assemble those and then copy them back to an HDF5 file. If that's what you want.
Scott, is Fuse then part of the 1.14 release?
Yeah. Mhm.
Okay.
Right now, subfiling is available in 113.2. Multi-dataset is supposed to be in 113.3, and then the official release will have them both in 114. So if you want to try out subfiling now, you can, and you just use the 113 release. Or the feature branch. We're still making some changes to the feature because it's still kind of under development. So if you want to use the most up-to-date, better performant one, you use the feature/subfiling branch. Otherwise, a little older one is in 113.2.
Okay.
But are the variables in the screen exclusive for the subfiling, or the stripe size I can query it for other I don't know, for general purposes, or should I still have to wait because they exist whenever it's going to be the 114?
No, they exist now. This
Okay.
is part of the, yeah. If you use it in 113, these all will work. We recently, actually, yeah, we changed it recently. So these are the up-to-date names of those parameters.
Thank you.
Mhm. That's all I have.
Scott, have you mentioned the HDF5 BOF at Supercomputing?
Oh, no, I have not. Yes, we will be given a BOF at the Supercomputing. Dana Robertson of the HDF Group will be there in person, along with Surin from LBNL and Quincy.
Mhm.
Right, Quincy? You'll be there in person.
That's the intention.
Okay.
Do you know
So
what-
join us at our BOF.
Cautious in COVID, you know, just, but anyway.
Yeah. That's always the wild card.
Do you know what day that is yet?
We don't have the assigned schedule, I don't believe.
Okay.
But Surin and Dana and I are meeting tomorrow morning to start discussing the presentation and all. So
Okay. Yeah, we'll announce that. Help me remember. But yeah, we'll announce that on the forum to make sure people know the schedule once we have that.
yeah, just a preview notion, getting it out there for people today.
Okay. Thank you so much, Scott, for hosting and sharing the preview. Again, the Zoom link to register for the webinar about subfiling and multiple access data sets. What was that? Was the other topic that's there in the chat. So please feel free to join us on September 30th. And we'll be back here next week. And I think it'll actually be John Reedy next week. So look forward to seeing everyone next week. Thank you, Scott, and everyone.
Thanks. Bye.
Have a good day.
Thank you.
Bye-bye.